There is a moment in every technological revolution when the pieces stop being individual curiosities and start forming a coherent picture. For Tesla's semi-program, that moment appears to be arriving right now, and the picture is forming as one that the commercial trucking industry has never seen before. The signals have been accumulating quietly, almost deliberately, across multiple fronts simultaneously. Massive manufacturing equipment appearing at Giga Nevada, confirmed production targets that defy conventional assumptions about what is achievable in heavy truck manufacturing, prototype sightings on public roads, a charging infrastructure build-out that only makes sense if enormous numbers of trucks are coming. And at the center of it all, a manufacturing technology so ambitious that even describing it accurately risks sounding like fiction. The technology in question is Giga Press die casting, and understanding what it is and what it makes possible is essential to understanding why the Tesla Semi-Gen 2 represents something genuinely unprecedented in the history of commercial vehicles. Tesla began developing its Giga Press capability in 2020, initially deploying it in the production of the Model Y rear underbody. The concept was straightforward but radical in its implications. Instead of assembling a structural component from dozens of individually stamped and welded pieces, you inject molten aluminum into a massive mold under enormous pressure and produce a single piece in seconds. The structural integrity is comparable or superior to the welded assembly it replaces, but the part count drops dramatically, the weight decreases, the manufacturing time collapses, and the potential for quality variation shrinks substantially because there are simply fewer steps where things can go wrong. Tesla scaled this approach aggressively. The machines grew larger. The castings became more ambitious. The Cybertruck structural design incorporated Giga Press technology at a scale that pushed the boundaries of what the industry thought was achievable in mass production. And now, with Elon Musk publicly musing about pushing to 50,000-ton pressing capability, and with the physical evidence accumulating at Giga Nevada, it appears that Tesla is preparing to apply this philosophy to the most demanding vehicle platform it has ever attempted, a Class 8 heavy truck. The first concrete signal appeared in late August 2025, when satellite and drone imagery captured the delivery of extraordinarily large manufacturing equipment to the section of Giga Nevada dedicated to semi-production. The scale of this equipment was immediately notable. Transporting it required 2 semi-tractors and a triple-axle trailer working in combination, an arrangement that speaks to the sheer mass and dimensional scale of what was being moved. In the manufacturing world, investments of this magnitude are not made speculatively. A company does not acquire and install a stamping or casting machine of this size unless it is committed to using it for high-volume production of large structural components. The investment itself is a declaration of intent. When you place that equipment delivery alongside what Elon Musk said at the shareholder meeting and in financial disclosures toward the end of 2025, the declaration becomes even clearer. Volume production of the Tesla Semi is confirmed for 2026. The transition from the Gen 1 trucks currently being delivered to PepsiCo and other early fleet customers to the Gen 2 architecture is not a minor revision. It is, according to analysts closely tracking the program, a comprehensive redesign that integrates the latest 4680 battery cell technology with a structural battery pack configuration that fundamentally changes how the truck is assembled. The battery pack in this architecture does not simply sit inside the truck's frame. It becomes part of the frame, contributing structural rigidity while simultaneously serving its primary function of storing and delivering energy. This eliminates entire categories of traditional assembly steps and replaces them with something faster, lighter, and more efficient. The rumors about 30-second production cycles deserve careful examination because they are both partially misleading and partially revealing of something genuinely important. Taken literally, the idea of completing an entire Class 8 truck from raw materials to finished vehicle in 30 seconds is not a meaningful way to think about manufacturing. No production process works that way. But the 30-second figure likely refers to something more specific and more technically interesting. The cycle time at a particular station in the production process, most probably a Giga Press casting station. When a 50,000-ton press injects aluminum into a mold and produces a large structural casting, the time from injection to part ejection can indeed be measured in seconds rather than minutes. And when that single casting replaces what would previously have been dozens of individual parts requiring individual fabrication, welding, and quality inspection, the aggregate time savings across the entire production process are enormous. This is the logic behind Tesla's unboxed manufacturing philosophy, which the company has been developing for its next generation of vehicles. Rather than moving a vehicle through a long sequential assembly line where each station waits for the previous one to finish, the unboxed approach manufactures large modules in parallel and brings them together for a final assembly step that is dramatically shorter than traditional final assembly. If the rear frame is a single casting, the battery pack is a structural element, and the cab components are produced through similarly consolidated processes, the time required at that final joining station can be reduced to something that seems almost impossibly fast by the standards of conventional truck manufacturing. Achieving Tesla's stated production target of 50,000 semi-trucks per year at Giga, Nevada, requires exactly this kind of manufacturing innovation. To put that number in context, the entire United States Class 8 truck market is projected to reach approximately 245,000 units in 2026. Tesla is targeting roughly 20% of the total market capacity in its first year of mass production with a vehicle that did not exist in volume form until recently. Conventional assembly methods, with their reliance on manual labor for hundreds of individual welding and fastening operations, simply cannot support that kind of output growth in that time frame. The only viable path to 50,000 trucks per year is to eliminate the steps that take the most time and require the most human intervention, which is precisely what Giga Press casting and structural battery integration accomplish. The charging infrastructure being built in parallel with the production ramp tells the same story from a different angle. The first 46 megacharger stations in the United States were captured in flyover imagery in early 2026, nearing completion and capable of delivering up to 1.2 megawatts of charging power. Infrastructure investment at this scale, requiring site acquisition, electrical utility coordination, construction, and equipment installation across dozens of locations simultaneously, is only justifiable if large numbers of trucks are coming in a relatively short window. You do not build a network for a few hundred vehicles. You build it for tens of thousands. The megacharger build-out is Tesla making a public commitment, written in steel and concrete, that the production ramp it has promised is real. Now let's look at the truck itself, because the Gen 2 Tesla Semi is not simply a refined version of what PepsiCo and DHL have been operating. Based on leaked images, drone footage, and reports from manufacturing observers who have been tracking the Giga Nevada facility, the Gen 2 represents a fundamental rethinking of what a commercial electric truck should look like, how it should be built, and what it should be capable of. The exterior transformation is immediately apparent, and it is not subtle. The gentle, almost friendly curvature of the 2017 prototype design has been replaced by something harder, sharper, and more deliberate. The visual language is unmistakably aligned with Tesla's cyber aesthetic, the same design philosophy that produced the angular geometry of the Cybertruck and clean, minimal surfaces of the Cybercab. This is not simply a styling exercise. Tesla is consciously building a visual family across its vehicle lineup, and the Semi Gen 2 joins that family with a front end that is flatter, more steeply sloped, and aerodynamically more sophisticated than anything that preceded it. The headlamp arrangement exemplifies how design and engineering have been unified in this redesign. The large traditional headlamp clusters of earlier generations are gone entirely. In their place is a slim horizontal LED light bar spanning the full width of the front fascia, functioning as a daytime running light and defining the truck's visual identity from the front. The primary illumination headlights are positioned lower and integrated more subtly into the front structure, maintaining effective lighting capability without creating aerodynamic disruptions at the leading edge of the vehicle. This arrangement directly echoes the Cybertruck's lighting design and reinforces the coherence of Tesla's Cyber family aesthetic while delivering real aerodynamic benefits. The windshield has been carefully reworked. The Gen 2 retains a wraparound glass configuration that gives drivers exceptional forward visibility, but the overall glass area has been reduced and the curvature has been more precisely engineered to minimize drag. The A-pillars are slimmer than before, a detail that improves both aerodynamic performance and driver sight lines. This is a kind of optimization that might seem marginal in isolation, but that contributes meaningfully to the truck's overall efficiency, when combined with every other aerodynamic refinement across the vehicle. Below the windshield, the front bumper has been lowered and redesigned to incorporate active air shutters. These are not passive openings in the front fascia. They are dynamically controlled elements that open or close based on real-time operating conditions. When the truck is climbing a grade under heavy load and the 800-volt battery system needs maximum cooling airflow, the shutters open to allow increased flow to the thermal management system. When cooling demand is lower, they close to present a smoother aerodynamic surface to the air flowing around the front of the vehicle. This feature has been common in premium passenger cars for years, but its application to a Class 8 commercial truck represents Tesla bringing a level of engineering sophistication to heavy freight transport that the industry has not previously seen. The camera and sensor suite visible on the Gen 2 prototypes is another area where the engineering intent is clear. Camera pods are mounted above the front wheel arches, protruding outward to provide the wide-angle coverage needed for a full 360-degree field of view with no blind spots. This layout is consistent with what would be required to support full self-driving capability in the future. It also replaces the large external mirrors that conventional trucks use, eliminating a significant source of aerodynamic drag and improving the overall efficiency of the vehicle at highway speeds. The dual benefit of better aerodynamics and better sensing capability from a single design decision is characteristic of how Tesla approaches engineering trade-offs. The body and chassis architecture underneath the exterior is where the manufacturing philosophy becomes most visible. Reports from multiple sources consistently point to Giga Press Gigacasting being used for the rear and mid-body structural sections of the Semi-Gen 2. Single-piece aluminum castings in these areas eliminate hundreds of individual weld points and dozens of separate components that would otherwise need to be fabricated, transported within the factory, positioned, welded, inspected, and finished. The weight reduction from this approach is significant on its own terms, but the implications for payload capacity are what matter most to commercial operators. In Class 8 trucking, the federal gross vehicle weight limit creates a direct trade-off between truck weight and cargo weight. Every kilogram saved in the truck structure is a kilogram that can be added to the load. Over the life of a truck that might carry millions of tons of freight, the cumulative economic value of even modest weight savings is substantial. The side skirts on the Gen 2 have been extended and reshaped to sit in closer proximity to the rear axles. This addresses one of the more technically challenging aerodynamic problems in heavy truck design: the turbulent airflow that develops in the space beneath the vehicle body. Air that enters the zone from the sides gets caught in complex vortices that create significant drag. By extending the skirts to minimize the gap between the body and the road surface, and shaping them to guide airflow more smoothly toward the rear of the vehicle, Tesla's engineers have targeted efficiency gains that add up meaningfully over the millions of miles a commercial truck accumulates across its operational life. The 1.7 kilowatt-hours per mile efficiency figure that Tesla has cited for the Semi is a direct product of aerodynamic refinements like this one working in combination across the entire vehicle. Inside the cab, the most significant revelation from Giga Texas sightings is the extended rear section that confirms the integration of a sleeper compartment. The cabin appears to have grown by roughly 50 to 70 centimeters in depth compared to the Gen 1 version, and the side windows have been repositioned further rearward in a way that is entirely consistent with the presence of a sleeping area behind the main driver's station. A properly designed sleeper compartment in a Class 8 truck typically includes a bed, storage space, and basic amenities that make multi-day operation comfortable enough to be practical. In the Tesla context, where the company has shown it takes driver experience seriously based on the overwhelmingly positive feedback from Gen 1 semi-drivers, the sleeper is likely to include features that set it apart from the Spartan sleeping quarters found in many conventional long-haul trucks.